Welcome to The Explainer. Today, we're diving straight into the actual DNA of video games. We're going to explore a really fascinating intersection that makes modern game design so incredibly compelling. We're talking about the psychological power of the gameplay loop, the total magic of intentional glitches, and the concrete technical reality of bringing your game to life on the web. Whether you play games, build them, or you just want to understand the secret sauce behind why we literally can't put them down, you are definitely in the right place. Think about this for a second. What actually makes your favorite gaming moments stick with you? Is it perfectly flawless, mathematically perfect design? Or is it the chaos? You know, those moments where the game kind of seems to break and you suddenly discover you can do something you definitely weren't supposed to? As we'll see today, the best developers know exactly how to balance both. So here's our roadmap for the explainer. We'll start with Act 1, the core design, then we'll look at Act 2, the chaos, and finally, Act 3, the code and deployment. Let's get right into it. Act 1, the core. You can think of this as the game's heartbeat. Before we can break any rules or even write a single line of code, we really need to lay down the philosophical foundation. Every single successful game, whether it's a tiny indie puzzle or a massive multiplayer online world, is built entirely on the gameplay loop. We define this as the core heartbeat of the experience. It's just a repeating cycle. The player does an action, gets a reward, uses that reward to upgrade, and repeats. If this cycle stops being engaging, the heartbeat flatlines and the game simply dies. Players just won't stick around, no matter how gorgeous your graphics are. Now, look at how these four pillars actually feed into one another. It's a rhythm. First, you've got actions, the raw inputs or the verbs of the game, like jumping or shooting. Second is feedback, those punchy sounds or bright visual flashes that tell the player, hey, your action mattered. Third are the rewards, the tangible loot or points you earn. And finally, progression, using those rewards to tackle harder stuff. This exact cycle is what creates that addicting state of flow, seen in everything from the rapid line clearing of Tetris to the crazy loot hunting of Diablo. But there is a massive trap here for aspiring developers. As the old industry saying goes, if your core loop isn't fun within the first 5 minutes, no amount of progression systems or polish is going to save the experience. If it isn't fun right out of the gate, you're essentially building what we call an empty loop. And an empty loop feels awful. It feels like a chore, like you're just grinding for meaningless rewards instead of actually playing. You absolutely have to hone that core loop until just interacting with the game is intrinsically satisfying. Moving right along to Act 2, the chaos. This is where bugs literally become features. Look, normally, a software glitch is a total nightmare. A game-breaking bug means crashed word processors, lost save files, and just endless frustration. But an intentional glitch is a totally different beast. It's a purposefully maintained flaw in the game's physics or code that gives players this amazing sense of agency. It lets them traverse the world in a really unique way, or maybe skip entire levels. Take one of the greatest examples in modern gaming, The Legend of Zelda: Breath of the Wild. Players figured out absolutely wild exploits in that game, pushing boats with their Magnus's power, flying across the entire map on frozen objects using stasis, or literally clipping through solid walls by shield surfing. And the craziest part? The game's director, Hidemaru Fujibayashi, explicitly told his team to leave these physics exploits in during playtesting. They purposely didn't fix them, because they realized that rewarding player creativity and experimentation made the game infinitely more fun. Then you have developers who go a step further and make the glitch the entire point of the experience. In the browser game Glitch Dungeon, created by Jake Trower, the whole inspiration actually came from his own early programming mistakes. In this game, you literally have to master glitches just to survive. You walk straight off cliffs into midair, you float around with this strange, choppy lag, and you can walk right through walls, though you disappear from view when you do it. It's all designed around this cool deal with the digital devil motif, where the game actively deteriorates around you, colors invert wildly, and raw strings of code just spill onto the screen as you play. Okay, so how do we actually build this? That brings us to Act 3, the code, bringing it to the web. So web games largely rely on the HTML5 canvas, but getting it to scale correctly is surprisingly tricky. See, a canvas is a replaced element in HTML, meaning it has a fixed internal pixel size, but CSS uses virtual pixels to scale its visual size on the screen. To make sure your game doesn't look like a blurry mess on modern high-resolution screens, like Retina displays, you actually have to dynamically scale the internal canvas up using JavaScript's window.device pixel ratio, all while using CSS to constrain the visual footprint. It's a really delicate dance between HTML, CSS, and JS. But what if you're going for that retro 8-bit look, kind of like Glitch Dungeon? You want those crisp, chunky pixels, right? To get that, you have to completely bypass the browser's automatic anti-aliasing. You do this by slapping on the CSS property image rendering pixelated. Then you use object-fit contain to make it fill the screen while keeping your aspect ratio intact. And if you're using a framework like Phaser, you set the scale manager to use scale, and this is absolutely crucial, you have to round your sprite positions to whole integers. If you don't, your art renders on a subpixel and boom, instant blur. Once you've got the visuals locked down, you need to structure your game's logic. Usually it follows a chronological state architecture, kind of like what we see in the Captain Rogers demo. It's a great structural blueprint. You start with a boot script to initialize the engine, move over to a preloader to download all your images and audio, transition to a main menu for your welcome screen, and finally hand off the baton to the game script. That's where that heartbeat update loop we talked about in Act 1 actually runs.
And to keep that core loop feeling perfect, your game's logic has to seamlessly adapt its control mapping across different devices. That's the huge advantage of HTML5. It runs anywhere, but that also means your loop has to feel good everywhere. You've got to map mobile interactions to touch pointers, desktop interactions to keyboard and mouse event listeners, and even hook into the browser's Gamepad API for a true console feel. Your code essentially acts as an invisible translator, turning all those different inputs into the exact same satisfying actions on screen. All right, final stretch, packaging and deployment, specifically launching on itch.io.
So here's your exact actionable game plan for uploading an HTML5 game. Number 1, you must combine all your assets into a single zip archive. Number 2, your entry point, which has to be named exactly index.html, must be sitting right in the root directory of that zip file, not buried somewhere in a subfolder. Third, your code has to use strictly relative file paths to find its images and sounds. And fourth, if you're calling out to any external leaderboards or APIs, they absolutely must be routed through secure HTTPS. Otherwise, the browser will just flat out block them. You definitely want to avoid these super common server pitfalls because they will instantly break your beautifully coded game the second you upload it. First off, do not upload .rar or .7z files. The system simply won't read them. Don't try to access open directory paths, or you're going to get a nasty 403 forbidden error. And please beware of case sensitivity. If your code looks for hero.png with a capital H, but the file is saved as hero.png with a lowercase h, it might run totally fine on your Windows machine, but it will fatally crash on the live web server and completely ruin your launch. Well, we've covered a lot today. The psychological flow of the loop, the absolute beauty of letting chaos reign, and the strict technical rules of web deployment. So, I want to leave you with a provocative thought. As you gear up for your next project, what glitch are you going to design into your game's core loop? How will you creatively subvert the rules to give your players an unforgettable experience? Think about it, get coding, and we'll catch you in the next explainer.